Now that we've detailed together the different casts in C++, we'll now focus on a little extra notion, the C++ typecast operators. It's a new syntax which will allow you to define your class's specific operators in order to make implicit conversions of your class to a type you're interested in. The simplest way to illustrate this is to show you an example. Here we'll consider a very basic foo class, having a simple constructor taking as a parameter a float and initializing this float with a _v attribute, as you can see. In this class, I can add what is called cast operators, which are the following syntax. I will use the operator keyword, followed by a space, then the type to which I can define an implicit cast operator in my foo class. Here I'll just code a cast to a float in order to return my float value. But I can imagine, for example, wanting to cast my foo class to an integer. Since the value I want to return is of course the one of my attribute right here, the code of the int cast operator will rather be a static cast of my float to an integer. Thanks to this little syntax, I'll be able to write in my code the following lines. We imagine that I'm creating an A instance of foo class, which I'm initializing with my arbitrary value. Thanks to these cast operators, I'll be able to initialize a B float directly with my A instance. Here we have an implicit cast from a foo type to a float type. The compiler will just go check if in the definition of my class, it can find a cast operator for floats. That's the case here. The action to perform is to root in my _b attribute. So here the value of b will the value of _b, which will be returned. But it'd also work if I wanted to initialize a C integer here. Since I'm initializing a C integer with my A instance, A is for the foo type, C is for the int type, so there's an implicit cast from foo to int. I'm looking at the definition of my foo class, and here I have an int cast operator. The associated code consists in static casting my _v to an integer, and returning the result value. So my C integer will be the result of the static cast of _v, and we can make sure of this by compiling, but we realize that it's a totally reasonable behavior. And it's very practical in case we want to use classes, having a behavior that is close to the one of the arithmetic class, or having a simple value. These operators will allow to cast implicitly when it's needed in an expression, our instance. So here the _v value will be displayed with the little assessor coded in the class. I haven't mentioned it, but you very likely saw it. And here my float has been initialized from my instance. And lastly, my integer which has been initialized from my foo instance, but this time with the int cast operator. We can see that we do get an integer value, while even through an _v was added the float type. So there you have it, cast operators. You can define them in your class. That's something very practical that you won't need every day. But sometimes it can be an elegant way to improve the expressivity of your class, to have more natural expressions. That's it for this little notion, and I'll see you in a moment for the next part.